So the first concept that I'm going to deal with is something that you already have, you know, dealt with before. What if you had constructors in inheritance? And just take a look at the code that I have. Actually, this is actually finished code, but we'll just run the same thing as it is. Um, so I have a situation here wherein I have a base class which defines one variable, public int I, and it also has two constructors, a no param constructor and an integer constructor. I also have a derived class which has one additional member j. And the derived class again has two constructors, one which is a no param constructor and one which is a parameterized constructor which takes two parameters. Right. So this is a concept that you've done before, and I would expect you all to participate, vocally and given a lot more responses. So my first question to you is, if I create an object of the derived class and I'm not passing any values here. First question to all of y'all, and y'all can actually given a response in the chat window. Okay, given a response in the chat window. Be a little quick on that. Don't take too much time doing that. So I know what y'all are all thinking. So my first question to you is, when you create a derived class object, are both constructors called? Is the base constructor also called? And is the derived constructor also called? Quick yes, no replies. Right? So correct, majority of you all are saying yes. So both constructors are called. Thank you. Stop the responses. If both the constructors are called, which constructor executes first? So what is the order of the constructors running? Which one will run first? Which will be shown the output first? Will it be the base or will it be the derived? Okay, so I saw one derived out here, but otherwise mostly base, parent class, base class, another derived I'm seeing. So let's reconfirm this. If I create a derived class object, now I've got two constructors out here. You'll find that the base class constructor will execute first, following which the derived class constructor will execute. Okay. Now I have two constructors from the base class. So if I create an object of the derived class which is not passing any parameters, which constructor of the base and which constructor of the derived would be called? So there are two constructors. There's a no param and there's the int constructor of the base. Derived class also has no param and int constructor of the derived. So if I create an object in this way, which are the constructors that would be called? This is the code out here. There's a base param, base int, base no param, base int, derived no param, derived int. Which one would be called on this line of code? Yeah. So the correct answer is no param in both. The first answer that I saw, Timmy, right, is
Yes,
correct.
sir.
All right. So let's confirm this. Let's run this code and confirm what we've been saying. So when I create a derived class object, you'll find that both of these are getting called, and the order of execution is the base gets called first, followed by the derived. And both of these, because you're not passing any values right now, both of these are right now the parameterless constructors, the no param constructors that are getting called. So you saw the output as base no param constructor followed by derived no param constructor. Let's do this in break mode and see what happens next. Okay, so I'm putting a breakpoint here, and I'm putting a breakpoint on the constructors as well to see what is happening here, which constructor is getting called. So let's run this. So when you run this in break mode, F11, of course, step mode to go to the next line. Now from this line, it actually first jumps to the derived class. It actually first jumps to the derived class. And why does it come to the derived class first? So we just saw that the base class ran first. Base class constructor ran first. But why does it first come to the derived class? What is the reason for doing that? Why does it come here first? Even though
Object
the
of base
derived,
class.
even though the base class is running first, why is it first coming to the derived class constructor? What does it come here and check out? What does it
Object of
first
base
find out?
derived class is created, so it will go first.
Right. But why does it come here? We saw that the base class constructor ran first. So what does it come here and check is my question to you. You can answer this vocally instead of typing it out. I'm not switching to the chat window.
Are there any variables to initialize?
No.
Uh,
What are you checking here? Why does it first come here?
It is
What does
taking
it first check out for?
derived classes means inherited from any class or not.
No. What is it that it comes here and checks? We just saw that it knows that it has to run the base first. We saw the output. No? Base ran first. But why is it first come to derived? What is it checking for?
Parameterless constructor.
What is it checking for? What is the question that it is asking itself?
Sir, it check the dependency is there any on the derived class.
It is checking which is the parent class.
And what else? More important, why is it coming to the, it knows what is the parent class. At compilation time, it knows this. But why is it coming here? What is the reason for it to come here? I'm not getting what you all are saying. You all are not giving me the right answer.
So like object is created from this class.
Correct. But why does it come here first? You saw that it ran the base class constructor first. So why is
Which
it
type
first
of
coming?
constructor need to call?
Correct. That is the answer. That is the correct answer. Who gave this answer?
Sir, me, Krunal.
Me matlab kya? How do I know who's you? Maybe
Krunal,
I'll give
Krunal.
you a name. Kunal. So say that. So Kunal is right. What you need to, what it comes and checks here is which constructor of the base class should it call? Now, have we told it which one to call? Have we anywhere given which one to call?
No.
No. So what does it call by default? By default, it will call the no param constructor from the base class. That's the logic it uses. It first comes and checks which one should it call. And if you haven't told it what to call, it actually calls the no param constructor of the base class. So now we haven't told it what to call. It's gone to the no param constructor. Now it runs the constructor. Now what is the base class doing out here? What is it doing out here? Yes. What is it doing? What is the code? I is equal to 10. What is it doing?
Initializing I value to 10.
Initializing the base class members. So now this code of initializing the base class members is already happening in the base class. And then when you come back to the derived class, okay, now this constructor runs again. Now I am reinitializing I to 10. Now should I be doing this then? This has already happened in the base class. So should I be doing it again in the derived class?
No.
No. So what should the derived class constructor only do?
Initialize the derived class members.
Correct. So it should only initialize the extra members that you have in the derived class, because the base class constructor is already initializing the base class members. So don't write the code twice. So derived class now should not do I is equal to 10. It should only do what? It should initialize the members of the derived class. Are we clear on this? And then of course, that's the code output that you saw. That's how we actually ran this. So I'll come back here and first thing I'll do is remove this code. Do not reinitialize the members in the derived class. Do it only in the base class. All right. Let's take the second situation. What if, for example, I am now creating an object of the derived class here, and I'm now calling the parameterized constructor. Parameterized constructor. And this is the code in the base class, and this is the code in the derived class. So my question again, now you can again type it in the chat window. My question again is, which constructors will be called? Which constructors will be called if I wrote down this line of code? If I did derived class O2 is equal to new derived class of, and I'm passing two integers out here. So which constructors will be called and in what order, of course? Right. So there are two constructors now, the base and derived. Right. I'm just seeing few responses. Can everybody please respond? Okay. 10 seconds more to complete this. Whoever is giving an output. All right. Please stop. So again, Timmy was the first one who gave the correct answer. And the correct answer is, since you are now passing two parameters out here, for the derived is going to call the parameterized constructor. But again in here, we have not told it which one to call from the base. We haven't specified anything. So by default, if you haven't specified anything, it will go and call the no param constructor from the base class. So the correct answer is first the base no param will run, followed by the derived int constructor that will run. Let's confirm this. Let's run this in step mode and see what happens. So from here, it will first jump to where? The derived class constructor, which takes two parameters. And the question again it's asking is, which constructor of the base should I be calling? If you haven't told it which one to call, by default, it will call the no param constructor from the base class. Achha, now what is it doing here? What is it initializing it to? What is the value it's initializing I to?
10.
To 10. But what value did we want it to be initialized to? I and J, we wanted to be initialized to what? 123.
123 and 456.
And 456 was for J.
Yes.
So now this should not be happening. We should not be running this constructor. Instead, we want to call the other constructor in the base class, which will initialize I to the value that is passed out here. We don't want to do this code. This code is incorrect. We don't want it to take a default value. We'd like it to take this constructor, which now picks up the value for I based on whatever the value passed out here. So that's the first change I'm going to be making. And if you go further, if you come back to the derived class, then I don't need to do this dot I equal to I. I don't need to do that because that will be done by the base class. So a couple of things. First thing is don't do this. Instead, now specify base of whatever. Now, when you say base of whatever, this allows you to specify which constructor from the base you want to call. So right now, of course, I'm giving call the no param constructor. I'm going to change that to take what? Pass the constructor which takes I as a parameter. So the value that it receives here as I, it's passing it to its base class constructor which takes one parameter. And let's try running the same code again. So here, now 123 and 456 being passed. This is being received as I and J. And we are now passing it to the base class constructor which takes one parameter. So base class constructor now receives this value of I and sets the value of I. After which we come back to the derived class, and additional properties that are there in the derived class would be set out here. So this is what would be an ideal situation. This is what you would ideally want to do out here. All right, this is a concept that you have covered before, so it's just being a recap of that same concept. The keyword used here is base. In C sharp, in Java, you would be used to writing it as super, but in C sharp, the keyword used is base. Are we clear on this, everybody?
Sir,
Questions? If it-
yeah.
Yes.
Sir, in line number 39, we have omitted the this dot I. So is it like we can't do it, or we should not do
We
it?
should not do it. We should not
Okay,
do it.
okay.
Why did you all yesterday I asked you all ki why have inheritance? What was the answer you gave me?
To avoid reusability of code.
Not to avoid reusability, to implement
Acha,
reusability.
to implement reusability. Yeah.
So now if you already got that code happening in the base class, then why would you want to, repeat the code out here? You reuse the code that is there in the base class and add on whatever other additional things. So
Yes, sir.
your strategy should always be that whatever values you have to pass to the base class, pass them to the base class. Let the base class do its job. And then after that, additional properties that you want should be now done in the derived class. Whatever the derived class properties only should be initialized in the derived class. Derived class should not initialize the base class properties. Let that be done by the base class constructor.
Yes, sir. Got it.
All right. Okay. And how do we call a specific constructor of the base class? Colon base of something. If you don't give that, then by default, what does it call? It calls the no parameter constructor of the base class. All right. So this is how you could work with constructors in here. Now in here, I have purposely done what? I have purposely specified them in separate constructors. But ideally, we should be writing how many constructors in the base class? Can we do this in a different way? Can we do this in a different way? Instead of having two constructors, ideally, what should be in this situation?
Named parameters.
Not name parameters, default values, right? So have only one constructor with default values. In yesterday's assignment, did you all create multiple constructors or a single constructor?
Single
How many
constructor.
of you all, how many of you all did it with multiple constructors? Did anyone do it with multiple constructors? Yes.
In second, I have to use a static constructor.
No, I'm not talking about a static constructor. I'm talking about a non-static constructor. Yesterday's assignment, both the assignments, you could have done it with one constructor, you could have done it with multiple constructors. So I'm asking those of you who have used multiple constructors, how many of y'all have used multiple constructors?
At first, I have written the non-parameter constructor to initialize it to the base values, to literals. But later on, I deleted it and also tried to run it. It ran well.
Right. So my point being that in yesterday's code also, I do not want multiple constructors. That is not the correct approach. Create one constructor with default values. That will be the better way of doing it. So if you have done it with multiple constructors, you need to go back and revisit that code and change that approach. Are we clear on this, everybody?
Yes, sir.
Okay. So this is what we're done with constructors in inheritance. Okay. I'm going to be later in the day giving you an assignment wherein all these concepts that we're doing right now would be implemented. So remember all these concepts. This is something that you've done before. It's just a recap of the same concept, slightly different keyword, but otherwise it's a recap of the same concept. All right, moving on. Okay, we're going to move on to another concept in inheritance. Let's assume we had this class employee that we created yesterday. Okay. And one of the methods that you had was calculate net salary. Right? And you had some code that you wrote on in calculate net salary. Now, let's assume that there are other classes that you create that inherit from employee. let's say class manager, which inherits from employee. And when you inherit from employee, you get all those properties and methods that are there in the employee class, including calculate net salary. So now this calculate net salary also is part of the manager class. Now, what if the manager class does not write like the implementation code of calculate net salary? What if the way of calculating the net salary of a manager is different from all employees? Now, what can we do in this situation? Because in this situation, by default, what have we got? We have got the same method has come in here. But we don't want that same method. We like to write some different implementation code out here.
We
So the
need to
manager
over.
class wants to write some other code out here for calculate net salary. Right? Write some other code.
Method
What can we
overriding.
do in this? What can we do in this situation? We can do three things in this situation. There are three possibilities that exist out here. The first possibility is you can overload the base class method. First possibility is you can overload the base class method. When you overload a method, what do you do with an overload of a method?
We
What are you
change the
talking about?
We
signature.
have a different signature for
Correct. So
same.
in overloading the method, the same name would be given of the method, but it will have a different signature. Right? Now, if you have overloaded that method, then obviously in the manager class, then you're giving calculate net salary with what? What will that have now? I'll have a different set of parameters out here if you're overloading it. And if you create an object of the derived class, so for example, if you create a derived class object here, you'll find that when you say dot, you'll find that both methods are available. What both methods are we talking about? What methods are we talking about? First is method from the employee class as well as method from the manager class. Both options are available here. So now you have the first option also available. You have the second option also available. When you say obj derived dot, you could choose which one you want to call. Okay. Now this may not be a desirable situation. You may not want that both methods should be available. What if you wanted the employee method should not be available at all through an object of the manager class? Right now, what is happening with overloading? You are having a different method for manager. But what is also happening? What is also showing up? What is also showing up?
Net salary method for employee.
Employee is also being shown up. Employee method get net salary is also shown up. So in certain situations, this might be okay, but in certain situations, this may not be okay. So what if it is not okay? Then what do we do? What are the options available to you? So here also you have two options available to you. The second possibility is you can hide the base class method. Right? What can the derived class do? It can hide the base class method. When you hide the base class method, in the derived class, you will give the method name with the same name, but this time with the same signature. You give the method with the same name and with the same signature in the derived class. If you did this, and if you did obj derived dot, you will find that only the derived class method is available. All right. So what are we doing here in this case? By giving the same name and same signature, what are we doing?
Overriding.
Yeah.
Darling, I'm saying you're hiding it. I'm writing hide out there. How can you read override out there? What is the spelling of override? How do you spell override? Override. When you write HIDE, what is that word? What does HIDE in English mean?
Hide.
Hide. So if I'm telling you hiding, why are you saying overriding?
Method hiding.
All right. So I'll repeat what I'm saying. By giving the same name and the same signature in the derived class, when you create an object of the derived class, only the derived class method is available. And this feature is called as hiding the method, hiding the base class method. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
This is not overriding a method. This is hiding a base class method. Overriding is a different concept. Clear?
Would it cause some conflict with the constructor name?
With the
Constructor name.
how would the constructor cause a problem?
So the class name and base name, since both are same, wouldn't it cause
So
some?
we are talking about the method name. We're talking about the method name.
Okay, sir.
Here we are, when we are saying same name, different signature, or same name, same signature, we are talking about the method that you are writing out here. We have started off our discussion by saying that we have a method called calculate net salary, which you don't want to the same code in the derived class. So we are talking about the method out here.
Yes.
Are we clear on this, everybody? All right. The third possibility that you can have out here is instead of hiding a method, you can override a method. You can override a method. Now, in overriding also, the similarity to hiding is that in the derived class, your method name will be the same name and the same signature as the base class method. And if you create an object of the derived class, then only the derived class method is available. If you did obj derived dot, then only what will be available will be what? Be the derived class method.
Derived class method.
So at this point, hiding and overriding are having similar characteristics. But there is a big difference between hiding and overriding. So what is the difference between hiding and overriding? Any method can be hidden. Right? You can hide any method from the base class. To hide a method, you don't need to do anything special. But to override a method, only a virtual method can be overridden. Right? So what is the basic difference between hiding and overriding out here? Any method can be hidden. But to override a method, the prerequisite is that in the base class, the method must be declared as a virtual method. And then only you can override it. Are we clear on this? What if it was not declared as a virtual method in the base class? Then what can you only do?
Hiding.
You can only hide it. What if it has been declared as a virtual method in the base class? Then what is possible?
Overriding.
Both are possible.
Sir,
Both are
what is
possible.
virtual method?
Yeah, I'll come to that. But if it's a virtual method, you can either hide it or override it. Both options are available to you in the derived class. If it is a non-virtual method, if the method in the base class is not marked as virtual, then what is the only possibility? If it is not a virtual method, then what is the only possibility?
Hiding a method.
Hide.
You can only hide it. But virtual method can be either hidden or overridden. So next question is, what is a virtual method? So virtual method is a method where the method to call is not decided at compile time, but instead is decided at runtime. I'll repeat again. In a virtual method, binding happens at runtime. Which method to call is decided not at the time of compiling your code, not at the time of writing your code, but instead at the time of running your code. Right? That's what you'd be doing out here. So virtual method is basically a late bound method. Right? Also called as runtime binding. Or another way of referring to it is with runtime polymorphism. Okay, what is, all of these things, what is happening? The method to call is being decided at runtime based on what object you are pointing to. Okay, this is how things are different for a virtual method. A non-virtual method, on the other hand, is the exact opposite. This is early bound code, or also called as compile time binding, wherein the method to call is decided when you have compiled your code. At that time itself, it has decided that. And at runtime, it does not change it. It does not depend on what object you are pointing to, but instead depends on what type of reference it is. Supposing I did this, for example. What is O now here? O is a
Reference of base class.
reference of type base class. And if it was a non-virtual function, if it is a non-virtual function, then the function to call is pre-decided at compile time. Depending upon what? Depending upon what?
Type.
Signature.
Not signature. Signature is the same, no? In the base and derived class, signature of the method is the same. Depending upon what? Depending upon what is the reference type.
Base
O is of
class.
what reference type? O is of what reference type?
Base class.
Base class type.
So now this is fixed. This is fixed for a non-virtual function. It will always call which method now? See, there are two methods. There's a method in the base class and there's a method in the derived class. So non-virtual, which will it call now? Always
Base class method.
base class.
Base class.
But if it is a virtual method, then supposing you had done this, O is equal to new base class. If I try calling a virtual method, then the method to call is not known when you have written your code, is not known when you have compiled your code. It is not decided at this time. Instead, this is late bound code. At runtime, When you try to call that O dot virtual, when you try to call it at that time, at runtime, it's deciding, it's very late bound, right? At that time, it checks for what? What object is O pointing to? What object is O pointing to? And based on the object it's pointing to, it will call that method. So what object is O pointing to right now?
Base class.
Base class. So what method will this call?
Base class
Which one will
method.
this call? The base class method. But instead of this, what if it was pointing to a derived class? You can have this. You can have a base class or reference point to a derived class. When you point it to a derived class and you try calling this now, at this time, what is O pointing to when you're calling O dot virtual? What is it pointing to?
Derived class object.
Derived class. So O dot virtual here will now, based on what is pointing to, it will go and call that method. So right now here it will call the derived class method. But a non-virtual function, this line does not matter. This line does not matter for a non-virtual. So whether it is here or whether it is here, this line depends on what? Non-virtual method depends on what? On which line? Does not depend on this line. Which line does it depend on?
The type of
Base class
declaration.
O.
Base class.
Base
So
class
what
of.
have we declared it as of type? Base class.
Base class.
So wherever you are, whatever memory you allocated does not matter. This has already been compiled time bound. So at runtime, it does not check what it's pointing to. It directly goes and calls what? Directly is calling what? Which method is calling here in the highlighted section?
The base
Base
class.
class function.
Base class method. So what memory you're allocating has no significance. It is not even checking at runtime. It's saying I will at compile time only decide what you have declared the reference of time. So that is the difference between a virtual method and a non-virtual method.
Non-virtual method.
Are we clear on this?
Yes, sir.
And I'll come back to what we are talking about. What can you override? What can you override? You can only override
the
what?
virtual method.
Only a virtual method. So if your method is not a virtual method, then overriding is not possible. On the other hand, for hiding, what method can you hide?
Any
What
method.
method can you hide? Any method you can hide. It doesn't have to be a specific type of method. Even you can hide a virtual method also, hide a non-virtual method also. If you hide a method, then it does not remain virtual, and then late binding does not work. Then only compile time binding works. Early binding happens if you're hiding it. Okay. Are we clear about this, everybody? About these concepts? We look at the code. I mean, I've not done the code with you. I will obviously be writing code for doing this. But at this point, are we clear about what we are talking about?
Yes, sir.
Okay. Any questions before I jump into the code?
So, asking about the practical implementation, can you mention where do we need overriding? Any example?
Okay. So if you have a situation wherein the object to call needs to be passed to you as a parameter as runtime. So while writing code, you write generic code. You write that, okay, I'm going to be calling an object of either the base class or the derived class or the sub-derived class. I'm going to call code for it. And which object to call can be passed to you as a parameter. Like for example, if you take this example, let's say we start with employee. So I declare a variable of type what? Of type employee.
Employee.
But allocate memory for either employee or any of his derived classes. I've just taken one there, but I could have many of his derived classes. So I allocate memory for any of its derived classes. And then I call this, let's say, calculate net salary. So now the net salary will be calculated based on what object you have created. So this gives you a little more flexibility in your code. When you're saying that at the time of writing code, I don't know what object I'm going to create. This will be created at runtime based on some conditions. And then I want to call the method. So the method that I'm writing will be the same. But based on the conditions that I have at runtime, which say that if something has happened, I want to create an employee. If something has happened, I want to create a manager. If the user says I want to create, let's say, a CEO, I'm creating a CEO. If the user says I'm creating a clerk, I'm creating a clerk. So based on that, you will create an object and then call the method. That code for calling the method will be the same. But based on what object you have created, it will go and automatically call the correct version of that function. So your code becomes more flexible with late bound code. Okay, understood.
Yes, sir.
All right, so let's take a few examples and then we can add questions again. So I'm stopping sharing for a minute. 1 second. Sorry. Okay, I'm stopping sharing for a minute because I don't want you to see what I'm copy pasting. The example that I have is a finished example, and I don't want you to see that code directly. We will work our way towards that code. So I hope you can see what I'm doing. Can you see what I'm doing now?
No, sir.
No? Okay, good. Because I don't want to show you what I'm doing. All right, I think I'm pretty set now. Sharing my screen again. Now visible? Yeah. Can you all see my
Yes,
screen now?
yes, sir.
Okay. All right. So let's take this situation wherein I have a base class. I got 3 methods in the base class. The first method I'm going to overload. Okay, first one I will overload. Second one I will hide. And the third one I will override. Okay, let's start with the first example. Overloading the method. This is simple. In the derived class, what will happen now? In the derived class, what are we doing now? Yes.
Same name and different signatures.
Correct. And when you create an object of the derived class, what would be available now?
Both methods.
Both methods would be available. So let's start with overloading the first method, display one, I'm calling it. And display one, this has a derived class display. And all that I'm doing here is specifying a string s. If I create an object of the derived class, obj derived dot shows you two versions of display one which is not taking parameters. Which one is this now? Which one is
Base
this?
class.
Base dot display one, and the second one dot display one, which takes a parameter.
String
Which
parameter.
one is this now? If you look at this, what is this now? Derived class dot display. So both of these now can be called. Right? So you had the base display followed by derived display. Both options are available to you when you overload the method. What have we done out here now? This one is overloading. Any questions about this one? First one. Simple.
So can you just re-show it how the flow went?
I'm saying that when I created the derived class, I just gave another method having the same name but a different signature in the derived class. Okay. And when you try calling this derived class object, we create a derived class object. If you try calling it, I'm saying both the methods are available. So this display one is method from where? Where is this one being written?
That is from the base class.
Base class. And this one is written in the
Derived class.
derived class. So I'm saying both the methods are now available to you.
Okay, sir.
Okay.
Yes, sir.
Right. So that was the first example. Let's try the second one. In the second one, what am I going to do? I'm going to hide the base class method. To hide it in the derived class, the method will have the same name and the same signature. And if you did obj derived dot, which method would be available to you now would be
Only
only
derived
the
class method.
derived class method. So I'm just going to copy paste this one. Same name, same signature. Of course, the code in there I will put in different. And I'll write it down as derived display 2. So when I do this now, and I come back to the derived class obj derived dot, when you try calling display 2, which one is it calling now? Can you see this? If you can read this, which one is it calling here? Derived class display 2. So you are now successfully hidden the base class method. No longer is available to you from an object of the derived class. I try running this now, it gives you the derived class display 2. All right. From an object of the derived class, now can I call the base class display 2? Is it possible to call the base class display 2 from an object of the derived class?
No, sir.
No, sir.
So what is this an example of?
Hiding.
Hiding the base class method. Okay. So while doing this, it's showing me a warning. So the green, underline there is your warning. So let's see what the warning says. Warning says derived class dot display 2 hides the inherited member base class dot display 2. Use the new keyword if hiding was intended. Are you clear on this?
Yes, sir.
Okay, now let's try and understand what the compiler is telling me. This is the compiler talking. Okay, now I'm not talking. This is not Vikram talking. This is the compiler talking. So the compiler is saying now that you have given the same name as the base class method. Are you sure you want to do that? Because if you do that, you're hiding the base class method. Maybe you didn't realize it, but base class also has a method called display 2. So when you're doing this, you are actually hiding it. Are you sure you want to do this? Who was saying this? I'm not saying this. Who said this now to you? This is the compiler. Compiler speaking. So now you want to tell the compiler, yes, don't worry. I know what I'm doing. Don't show me a warning. I know what I'm doing. I want to do hiding. Okay. And to do that, you can use a new keyword. When you give it a new keyword, you are telling the compiler that yes, I am doing hiding. And the compiler does not show you a warning. Now, what is the difference in the way in which the code ran? No difference. The output is exactly the same. So if you run this again, it's exactly the same thing that's happening. It's doing hiding with or without the new keyword. Both are doing hiding. What are the new keywords simply doing out here for you? What are the new keywords simply doing for you?
It is
Confirming that
telling
you are
this
hiding.
compiler that we are hiding intentionally.
And what else you're telling the compiler? Don't show me the warning. So by giving the new keyword, the compiler does not show the warning. If you don't give the new keyword, the compiler shows the warning. Both of which are doing hiding. Both of which are doing hiding. It is not that one is hiding and the other is not. So without new also it works the same way. With new also the same way. Only the warning is shown or not shown. Are we clear on this? Questions, if any?
No, sir.
All right. So let's move on to the third one now. In the third one, we want to override the base class method. So again, what is common here is what method will have the same name, same signature. Right? And if you create an object of the derived class and do a obj derived dot, only the derived class method is available. So all of this is same as before. But the big difference is what?
Virtual method.
Only a virtual method can be overridden. So if you come down to this, prerequisite is what? Method needs to be a virtual method. If you don't mark it as virtual, then you cannot override it. Okay. Let's come down to the code out here and let's see public virtual as I'm typing it out. See what happens when I press the spacebar here. It should actually. Error in my code. Why is it not showing this? Public virtual it should show you this something wrong. Let me build a project again. Everything okay? Close it once and open it again. Maybe it's just a Visual Studio bug. So what I wanted to show you was that there's some IntelliSense coming out there. That IntelliSense was not being shown to you. So, which is why I've closed this and opened again. Hopefully it should come now. So what I wanted to show you here was this public. This will show me starting IntelliSense. Public Oh, I did virtual, did I? I did a type out virtual. Oh, that was my mistake. It was my mistake. It was not Visual Studio. I'm doing this. So in the derived class, the keyword that you would use is override. I gave the wrong, my brain is fried right. So when you say public override, okay, override, and I give a space here. Okay. Yeah, it was my mistake. I think I was typing out public virtual, all right?
Yes, sir.
So public override, and now it shows you all the virtual methods out. So if you look at this, display3 is the virtual method that I have written in my base class. But in addition to this, you also get the other methods which are equals, get hash. So where have these been defined? Where
Object
have
class.
these virtual methods been?
Object class.
Object class.
Right? Okay. So if you look at the override keyword, public override, that's how you're overriding it. It only shows you all the virtual methods from your base class. So display 1, display 2 is not being shown to you. And I can choose that display 3. And of course, it doesn't generate the code. It's just showing you base or display 3. And I can come and change whatever code that I want. Derive dot display 3. So this is the mistake that I was making earlier. I was just giving virtual. I need to mark it as override. Now, when you give the override keyword, this function also is a virtual function. So how do you create a virtual function? Either by giving the virtual function, or in the derived class, you mark it as override. When you mark it as override, this function also continues to be virtual. Right? Let's try calling the code. And here, instead of calling obj.display2, now I want to call obj.display3. Okay. At this point, is there going to be any difference between these two methods? At this point, will they be the same or will they be different?
So ideally, it should be same.
When I mean same or different, it means that both of these I want to give you what? The derived class display3. So look at this, it's calling derived class display3. And you'll find that at this point, there's no difference between what you're hiding and what you're overriding. So output is similar for both of these. Change come up. When would the change come up? If you're trying out late binding, that's when the difference would be shown up. So I'll show that in the next example. But for now, the overriding is very similar to the output that you're getting with hiding. Are we clear on this?
Yes, sir.
All right. So this is an example of overriding. All right. Any questions at this point of time?
So the virtual and the override part, is it like we in the base class we have to declare it as virtual and override in the derived? Is it like that?
Yeah.
Okay.
Okay. So what if I didn't give it as virtual in the base class? What if I didn't give it as virtual in the base class? Then what will happen? Why is this showing me an error?
Because
I've
without
removed the virtual keyword.
it is
So it gives you an
mandatory.
error now saying that you cannot override it because it is not marked as a virtual method. So prerequisite is what? To override it, you need to mark it as virtual.
Virtual.
Correct? All right. What if I don't give the override keyword? What if I don't give the override keyword? Any guesses what it will do for you?
Warning.
Hiding.
Correct. My question was, if you don't give the override keyword, then what is the problem out here? What is it doing by default? It is hiding the method. So again, it's showing you a warning. Let's read what the warning says this time. So derived class dot display 3 hides. It's hiding. Okay, hides the inherited member base class dot display 3. To make the current member override that implementation, add the override keyword. So what are they suggesting? Add the override keyword if you want to override it. Otherwise, add the new keyword. So what is it doing by default? By default, what is it doing? It is hiding.
Hiding.
If I don't give any keyword, will it still hide it? Will it still hide it? Yes. By
Yes, sir.
default, what is it doing? It's still hiding it. Now, if you want to override it, what keyword do you need to give? You give the
Override.
override keyword. And if you don't give the override keyword, the compiler says, please give the new keyword to tell me that you know what you're doing. So this is doing what now? This is also hiding it. You remove this, this is also hiding it. But to override it, you need to give the override keyword. Clear on this so far?
Yes, sir.
All right. So let's try the situation where they will be different. So far they have worked similarly. Now in what situation will they be different? Right? If you can go back to what we were doing out here. What will we need to do here to try out the difference? What will late binding do? You declare a reference of the base type, but allocate memory for either the base class or the derived class. And that's where the difference between virtual and non-virtual functions will be shown. So let's try doing this. I'm changing this code a little bit. And base class O. In the first case, I'm making it point to new base class. And I try calling O.display2 and O.display3. I try doing this. What will be the output for both of these? Which method will it show? Will it show the base class method or the derived class method?
Base class.
Base class.
Base class in both of these.
Yes, sir.
So let's first confirm the output. So in both cases, it's showing you the base class method. Right? Base display 2 and base display 3. But the way in which it is working is entirely different. The way in which this code is working for these two lines is poles apart. So this line, O.display2 on line number 64, this line, this is the non-virtual method, which is early bound. Okay. It depends on what? The reference, how it has been declared. So what are the reference that we are using out here?
Base
Base
class.
class
Oh.
reference.
Base class O. So what will this go and call?
Base class
Go and call always
function.
base class O. On the other hand, the virtual function, which is late bound, also called as what? Runtime binding. This depends on what? On the object that you have created. So what object are we creating here?
Oh, new base class. Line number 63.
O is equal to new base class. So this display 3 at runtime, it will find out what type of object its O is pointing to and then go and call that. Now, if you want to see the difference what I'm going to do here is this. Instead of saying O is equal to new base class, I will say O is equal to new derived class. At this point, what is it pointing to now? What is it pointing to now in this case? Is your derived class. Right. What about O dot display to? What is it always called?
The
Base
reference
class.
base class.
The reference is not changing. Agree?
Yeah.
This line is not changing. But what you are pointing to, that could change. So when you call O dot display 3, O dot display 3 now will depend upon this line and will call you the display 3 from the derived class for the second one. So this is where the difference is shown. Let's try running this code. And base display 2 and derived display 3. Are we clear on this? Yes?
Sir, one more question.
Mhm.
Sir, if we don't write the override method in the derived, okay, and there is virtual present in parent, then if we perform the same thing, then will it go
Then
to
what is
parent?
happening right now? What is happening right now? When you first thing is tell me what happens on line 100. What is it doing right now?
It is trying to hide.
It is not trying to hide, it is hiding.
It is hiding, yeah.
Okay. So it's hiding this method.
Yes.
Now, if you're hiding this method, it is no longer a virtual method. Only when you override that method, it is a virtual method. What
Okay.
did I tell you in the base class? If it is virtual, and
Mhm.
if you give the override keyword, that override is still making it virtual.
Right.
But if you don't give the override keyword, then it's no longer a virtual method. So if it is no longer a virtual method, will late binding work?
No, it will not work.
Late binding works only for
Virtual methods.
virtual methods.
Yes.
So if I now run this code, I'm not going to run the code, but if I now run the code, what will you get out here?
Display 3 of base.
Base. Why?
Because the
It
method
is not
in
a virtual
derived is,
method.
yeah, it is not a
Because it is
virtual
not a
method.
virtual.
Yeah.
If it is not a virtual method, then what's going to happen now? Early binding.
Early binding, yes. Clear, sir.
If you run this now, right? You got the base display 3. Okay.
Yes, sir.
So if you want late binding, it only works for virtual method. How do you
Virtual
give a
method.
virtual methods? How do you give a virtual method? What are the two ways that you have seen so far? One way is with the keyword virtual.
Yeah.
Second possibility is in the derived class, you will not use the virtual keyword. What will you use now?
Override.
Override.
Yes, sir.
Yeah. Questions, if any?
No, sir.
Okay. So I have a few questions for you. Which will be faster? Early binding or late binding?
Early binding, sir.
Early binding. Why early binding?
It is
Correct
decided at
answer.
compile time.
So at
Which
compile
method
time,
to
it
check.
only it knows what to call.
Yes,
It
sir.
is not at runtime, it is not checking what object am I pointing to. Then based on what object I'm pointing to, it will call that correct function. So every late bound call that you make, is it going to run slower or faster or the same speed at the early bound call? Every late bound call, will it be faster or slower or same speed as early bound call?
Lower, sir.
Much slower.
Yes.
Agree? So early bound code will work faster than late bound code.
Yes, sir.
But what advantage you get in late bound code that early bound code does not give you? What does late bound code offer you that early binding does not?
Runtime polymorphism.
Decide
At runtime.
decide
Correct.
method call at runtime.
Correct. All three answers, all those who said give the answers are correct. So you get the flexibility of deciding which method to call at runtime. It's more flexible approach. Correct or no? Now, do you
Yes, sir.
always need this approach? For every call that you're making, do you need the flexibility?
No, sir.
In certain times, you'll need this. But are all methods, is it better to write early bound code or late bound code?
Early bound
Early
code.
bound code.
From a performance perspective, I'm just talking from performance. If you want flexibility, then what? Then late bound code, no other option. But if you don't want flexibility in every call that you're making, then early bound is much better. Agree or no?
Yes, sir.
Agreed, sir.
Right? And that code will far outperform any late bound code that you're calling. Agree or no?
Agreed,
Early
sir.
bound code far outperform any late bound code.
Yes, sir.
All right. I'll take you back to that notepad file of mine where I was typing it out. Here, sorry. And I wrote HIDE hide, and one of you said this is overriding. Correct? Something like that happened some time back. While I was doing this topic, I said hide, and one of you said no, this is override. So I'm writing hide, but you're in your mind you're saying no override. Then that happened right now, right? So
Yes,
why
sir.
did that happen? Why did that happen? Why did that happen?
Maybe, sir, we are conflicting with the Java concepts.
Correct, correct. Because you have a hangover of Java. Correct? So in Java, you had never heard the term hiding. In Java, you had never heard the term virtual method. Right? So why had you not heard that in Java? And why in .NET are you now having two concepts, hiding and overriding? Because in Java, when you write a method, by default, all methods that you write are virtual methods. In Java, all methods that you write are virtual methods. All methods are virtual by default. Whether you like it or not, the method is virtual. Okay. And therefore, you don't need to give the virtual keyword, you don't need to give the override keyword. And what we called as hiding here, you are calling it as overriding in Java. Because all methods by default are what? Are all anyway virtual. So no keywords need to be given. So which is why there was a confusion in your mind. Correct?
Yes, sir.
All right. In .NET, that is not the case. In .NET, all methods are by default non-virtual. And if you want to make them virtual, you have to give the virtual keyword and then you have to give the override keyword. Okay. So why has .NET taken this approach? Remember on day one, I told you that
To increase
.NET code
performance.
far outperforms Java code. In .NET code, performance is far better than Java code. One of the major reasons is this. In Java, every call that you make is a late bound call, runtime binding. In .NET, all calls that you make by default are what? Early bound. Understanding this?
Yes, sir.
So naturally, this code is going to early bound code that we are writing is going to work much better than late bound code. So in Java, why have they made that? They said, no, what if you want the flexibility? What if you want the flexibility of which method to call deciding at a runtime? So in .NET also that is there also. But that is not required. No, every call is not required. You agree with this or not? In some calls you will require it. But every call will not require this flexibility. So this is what .NET has done. And this is why .NET code works much faster than Java code. This is one of the reasons. It's not the only reason. There are optimizations all throughout .NET. At every place that you can think of, .NET has far optimized this code much better than Java. And the advantage that .NET has, what Java came in first. So they saw, and they saw, okay, this is what is going wrong out there. So we can improve on this here. That will always happen. Now something comes up after .NET. They will see what mistakes .NET is making and they'll improve on those mistakes. That's very natural. No? The next thing that comes up is always slightly better than the previous thing. Yes, sir.
Yes, sir.
So this is why you all had this confusion. Which is why I didn't want to scold you there, but I wanted to make that point so that you understand what is happening out here. So when I wrote hide, you said override, and my intention was not to scold you, but just to make you remember that what is the difference between .NET and Java in terms of why things work in a certain way in Java and why things work in a certain way in .NET. All right? Okay. Yeah, I think I have got a lot of instances of Visual Studio running in it, and that's actually slowing me down. Let me just close the ones that I don't need. Okay, so let's take this example further. Okay, and we have right now done what? We have marked this method as virtual in the base class. In the derived class, we have come and given what? Override.
Override.
Now, when you give it as override, this method also is a virtual method. So what if, for example, I had a situation like this, wherein I have now a sub-derived class. I have a sub-derived class. Can the sub-derived class also come and override it further? Yes or no? You think this should be possible? Agree? You think this should be workable?
Oh, yes, sir.
Right? So remember, when you override a method, this method is also what? This method is also
Virtual.
virtual method. And in my sub-derived class, so area manager inherits from manager. In this, what am I doing again? I'm overriding that virtual method. Is this method also virtual now?
Yes,
Again,
sir.
I'm giving override. Is this also virtual? Yes.
Yes.
So the virtuality continues. So you can say virtual override, 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 override. All throughout you can give that. And this would work fine. So let's come back to our code. And I'm going to create a sub-derived class. Which inherits from the derived class. Okay. So the sub-derived class is like in my example, I've taken area manager, right? Which is inheriting from manager. So same way, sub-derived inherits from derived. And what can I do again now here? Public override. And again, it's showing me what? Display 3. And I can now go and override this method again. And this was, I'll just change the statement to sub-derived display. So this is possible. Now, if this is possible, do you think I can do this as well? Instead of pointing it to derived class, point it to sub-derived class and then call display 3. So what will it call now here on this display 3? What is it pointing to? Yes?
Sub-derived class display method.
Sub-derived display 3. So that late binding can be also done for the further classes down the line in the hierarchy. So you'll find that this also works. Subderived display 3. Right? Any questions, any doubts about any of this?
No.
Okay, let me give you a parallel example, another example similar to this. Let's say I had a class called shape, okay, and in which I had a method called calculate area. Very similar to the previous example. Okay. And I create a class called, let's say, quadrilateral, which inherits from shape. And here, what will you do in this case? Instead of virtual, this would be override.
Override.
Then I create other classes down the line. So maybe, for example, I create a class called square, which inherits from quadrilateral. And this also does an override. Now, consider this possibility. What if, see, this is the way in which you're calculating the area of any shape. Now, this has been improved upon and saying what? This is the way in which you're calculating the area for a quadrilateral. Further improved upon, and this is the way in which you're calculating the area for any square. Okay. Now, let's say that the way in which you calculate the area for any square is the best possible way of calculating the area. There can be no better method for the way in which you're calculating the area for the square. Now, in such a situation, the square class does not want its method to be overridden further down the line. Why doesn't it want it to be overridden further down the line?
Because it is the most optimized method.
Correct. Because it is saying that this method is the best way of doing it, most optimized way of doing it. I don't want anyone else to come and override this method further. Now, right now, if you try to override it, let's say, for example, let's say if I take a class that's a square, let's say a chessboard, for example, right? And the chessboard inherits from square. So chessboard right now class, and all chessboards are square, for example, overrides this calculate area, can override it. Now the square is saying, I don't want this to work. I don't want any further class down the line to override it. Such methods, what you can do is you can mark them as a sealed method. Very similar to a final method that you learned in Java. So sealed method is a method that is a virtual method. See this, is this a virtual method? Is this method a virtual method?
Yes, sir.
Yes. So sealed method is a virtual method that cannot be overridden in further derived classes. Now if I mark it as sealed and I try doing this, then this gives me an error. What is the error now? What is the problem now? We cannot override something that is sealed. So sealed is stopping the virtuality, stopping it from being overridden further. Clear on this, everybody? Yes.
Yes, sir.
Any
Understood.
questions? Any questions about this? Right? You have learned this concept before in Java, like a final method. Now, let's try doing the same thing in our code out here. I don't have these classes. I am calling it derived, subderived. So I'm going to create one more class here. Let's just call this subderived, which inherits from subderived. And right now, of course, subderived can be overriding it. If I wanted to stop it from being overridden further, all that I do is what? I mark it as sealed. When you mark it as sealed, immediately here it's giving an error. What is the error here in this case? without showing you the error message. Can you tell me what the error message is?
Display 3 cannot be overridden further.
Because it is a sealed method in the
method.
base class. Clear on this? So you obviously can't give the override keyword. But if I remove the override keyword, this works now. So what am I doing here by default now? What is this doing?
Hiding.
Hiding.
So can you hide it? Can you hide
Yes,
it?
sir. Yes, sir.
Right? Remember what we said earlier? We said earlier was that any method can be hidden. But for you to override it, only a virtual method can be overridden. So warning is still there. How do I get rid of the warning? How do I get rid of the warning?
A new.
New keyword. Will it work the same way without new also? Of course, yes. So let's try this now. Let's try this. So what if I come back here into my code now and I'm going to try out one more thing and let's see whether you know the output. If you've tried it before, you would know the answer to this. What if I did sub direct? Right? What if I did sub direct? And what do you think display 3 would give me in this case? Any guesses on what the output could be?
Base
Yes.
class.
Okay, I'm not saying no. Sub-derived class. Okay. So who's the girl who gave the answer second?
Sir, me, Shivani.
Me, and don't say me, no. Okay.
I.
You say no, not I. Say Sir Shivani, because me means what? I have no you. I don't know who it is who's talking. So yes, Shivani is given the right answer actually. So what happens here is this. When you declare the method in the base class, it was a virtual method. Now it has been overridden in the derived class. It has also been overridden in the sub-derived class, but the sub-derived could not override it. So when you try printing sub-derived, it will give you the last point up to which it has been overridden. And the last point where it was overridden was the sub-derived class. So when you try running this now, the output that you get is this sub-derived. So Shivani was correct. The other person said base, and that is not correct because it was virtual up to a certain point, and it stopped being virtual after that point. So up to the point it was virtual, it would override it, but after that point it won't.
Sir, but binding it's at compile time, right? For the hiding.
Yes, but this is now to reach sub derived. You have to go through a hierarchy, no? How did the sub derived get created? Through a hierarchy of classes. So when you are declaring this of type base class, in the sub-derived it is not late bound, but up to a certain point it was late bound. So it will give you the last point where it was late bound. Okay. Earlier we tried it with only base and derived. We tried this only. Somebody had asked the question that what if I don't override it in the derived? You tried only with base and derived. So now derived didn't override it. What was the last point where it was overridden was base. So it gave you base. So here now what is the last point overridden was sub-derived. It gives you that.
Means sir, it is still lead bound, right? For
up to the point where you were giving override. At what point you stop giving override?
No, what that I understand. What I am saying that in the sub-derived class we override it, so it is lead bound. So how it
is not late bound. That's what I'm trying to tell you. It is early bound here, but up to the earlier point it was late bound.
Okay.
You have declared a variable of type what? Of base class. But overriding did happen to get to sub-derived. You were first passing through all these objects. The hierarchy passed through all of that. So it is overriding it up to a certain point. After that point, it's not. So it is not, if you're asking me, is it late bound in sub derived? No, it is not late bound in sub derived. But
No,
is it
that
late
I
bound
got
in
it, sir.
sub
But
derived? Yes.
that I got it. But what is my question? How it is early bound? Because
Only in here. Only in here. Only in here. So if you see what I'm trying to say is here that base to this, it didn't allow that. But up to a certain point, it was late bound. So that it will take up that point. That's the point I'm making. It is from this point onwards, it is early bound. But up to this point, it was late bound. So up to the point it was late bound, it will take that up. That's the point I'm trying to differentiate between. You're saying, is it Boolean true or false? Is it late bound or not? I'm saying up to a point it is. After that, it isn't. Understood?
Okay, sir.
The function in sub derived would be early bound. But you started off by declaring a variable of what type? Of base class type. No? So in base class, you did say it was late bound. You did say it was late bound. Here also. Here also you said late bound. And here is where you stopped. Anyway. Okay, I'm going to make one more statement here. Okay, I'm going to make a statement here and tell me whether you think my statement is correct or not. If you think it is not correct, tell me why, the reasons why you think it is not correct. And if you think it is correct, tell me the reasons why you think it is correct. Okay, so listen to the statement that I'm making. The statement that I'm making is that for a sealed method, this is a sealed method. For a sealed method, sealed must compulsorily be given with override. Sealed must compulsorily be given with override for a sealed method. True or false? And your reasons for saying so.
True, because sealed is used for a virtual method, and virtual method is only when we override it. Means when we declare override, it is by default virtual, and we can seal it. So both should be done at same time.
So why can't I do it without it? Without it,
If
is there
if
any
you do
other
not
possibility?
if you do not declare virtual, so it is by default a non-virtual. So we don't need to seal it.
Okay. Anyone else has any other opinion that you would like to share?
Sir, we can declare, but we should not declare.
So that means you don't agree with my statements. I'm saying it's compulsory, but you're saying no, it's possible to not compulsory. That's what you're saying. No? You're saying if you're saying we can declare it.
Actually, sir.
One second, let me just complete talking to whoever is saying that. If you're saying
Yes,
we
sir.
can declare it, that means you don't agree with my statements. Correct?
Yes, sir.
Okay. Anyone else?
So we should seal it because we use sealed keyword while overriding, right? To stop overriding the method. If you are not overriding any method, then there is no point of writing seal.
Okay, which is what the earlier person also said. Okay. Anyone else? Any other?
So seal is also having the features of virtual. So if we declare the first method at seal itself, we cannot override it. So we can write it without override also.
So you don't agree with my statement?
No, sir.
Okay. Anyone else would like to share their opinions? All right. So listen to what I'm saying. So firstly, the statement is true. Okay. The statement that I made is true that seal must compulsorily come with override. Okay. Now consider this. The point that people made was also correct, but they didn't address the issue that I'm trying to raise out here. So the point, both the girl who spoke and the boy who spoke before her and who agreed with me and said what they said was also correct. So first thing is, when are you sealing a method? You're sealing a method with which is a virtual method. So if the method is not virtual, you can't give sealed. Correct? That is the point that they were making. That if the method is virtual, then you can't give it as sealed. Sorry, if the method is non-virtual, then you can't give it as sealed because it anyway is not a virtual method. Agree?
Yes, sir.
Right? So all non-virtual methods you can't give sealed. First thing. Now, how do you give a virtual method? What are the two possibilities of giving a virtual method? Either you give the keyword virtual or you give the keyword override. Now, supposing I said sealed virtual. Supposing I said sealed virtual. Is this statement okay or not okay? Sealed virtual. Is it okay or not okay?
Not okay.
Not okay.
Not okay.
Why?
Not okay.
Why?
Because we
Why?
are giving virtual just to override the functionalities of that method, and alongside we are just giving seals to stop the overriding for that method.
Correct.
So both are
Correct.
contradicting. So we just cannot use the same word for that.
Perfect. Perfect. Agree. So virtual says you can override it, but sealed says you cannot override it. So both of these are exactly opposite in meaning. So if they're opposite in meaning, that means you cannot give sealed with virtual. Compiler will not accept it. The compiler will say, make up your mind. Do you want to allow it to be overridden or do you not want it to be? If you want it to be, leave it virtual. If you don't want it to be, then leave it. Then you can't, say sealed and virtual at the same time. So you cannot give it with virtual. So what are the only place that you can give it with? What does that leave out? What are the only other option? Is with override. So the sealed keyword must compulsorily come with the override keyword for a sealed method. I'll repeat again. For a sealed method, the keyword sealed must compulsorily be given with override. Otherwise, it will not work. It will give you a compilation error. Are we clear on this? Right. Any questions, any doubts about any of what we have done so far? Okay, I'll just copy pasted that same explanation that we put out there. I've copy pasted that here as well. Okay, let's move on to another topic in inheritance itself. Consider this situation. Let's say you're creating the employee class and this had all these yesterday's class to create properties like you had employee number, name, so on and so forth. Basic, right? So on and so forth. Whatever other properties that you had. Then you had some methods out here, calculate net salary. Right? Now, I had other classes that inherited from employee. So I have clerk, manager, okay, other whatever, let's say salesman, salesperson, whatever. Whatever, executive, right? And so on and so forth. Multiple other classes that we have, whatever. Let's say programmer, programmers also employees, of course. Let's say whatever, CEO, and so on and so forth. Whatever other classes that you can think of, you have created these classes. So every possible type of employee you have come and created. Right? Now, given this situation, I'm saying every employee is a certain type. Would I then need to create an object of the employee class? Would I need to do this? Employee O is equal to new employee. Would this be required?
No,
Why not?
because
not?
because we can create employee O is equal to new clerk.
Correct. Because now, what does this main employee object, what will it do? Nothing. No? It by itself, it may not mean anything. What will the employee do? He has to do some role, no? He has to perform some job. Or is he going to just come and take his salary and go away? He has to perform some job. So you cannot be just saying this employee O is equal to new employee. This is not allowed. Or not, this is not allowed, but this should not be allowed out here. We don't want an object of that class to be created because by itself it may not mean anything. So then, can I delete the employee class? Can I delete the employee class and say that no, I don't want to keep this at all?
No, sir.
I'll delete the employee. Why? Why can't I delete it?
Because you can inherit this in clerk manager.
So why would you want to inherit from there?
Code reusability.
Right. So common code that you have would go into the employee class. Common code would be in the employee class. But we don't want an object to be created out here. We don't want this line to be happening out here. We do want to retain the class for giving rise to other classes. Now such classes, you can mark them as abstract classes. An abstract class is one wherein you cannot create an object of the class, but you can what?
Use reference.
You can inherit
Override.
from that class. Inherit, not override. We are talking about inherit from that class. We are talking about a class. You don't override a class, you override a method, right?
Yes.
So you don't want to create an object of the class, but you want to be able to create a derived class. You should be able to allow to inherit from that class, use it as a base class. Such classes, you could keep them as abstract classes. Are we clear on this? Correct? Understood? Okay. So that's the first concept that we're going to try out, how to create an abstract class. To create an abstract class is very simple. You just give the keyword abstract and it creates an abstract class. When you create an abstract class, you'll find that you cannot create an object of that class. That line will give an error. But what will be allowed here will be what? You can inherit from that class and create your derived classes that get in the methods of that class. Clear on this, everybody? All right.
Yes, sir.
Okay, next concept. In .NET, an abstract class may optionally, not compulsorily, but may optionally have pure virtual functions in there. Right? I'll repeat, an abstract class may optionally have a pure virtual function, one or more pure virtual functions, not compulsorily. So what is the pure virtual function? In object-oriented terms, what do you understand by a pure virtual function?
A function which is only declaration.
Correct? Carry on more. Explain further.
It will not have the
It will not have the code body. It will have only a declaration.
Yes,
And what else?
Compulsory needs to be overridden.
In where?
Subclasses.
Subclasses.
Okay. Now, why do you make me prompt you with this? Can you not, you know the information, no? Can you not provide the information all at one go? If you're going to go and give an interview, the interviewer not going to be as kind as me and sit and probe you. Acha, now after this what? After this what? After this what? So say the whole sentence, give out the information. Why does it have to be extracted out of you? Why do I have to sit like put you on a torture chair and tie your hands and legs and say, now give the information? Why do I have to do that to you? Why can't you give this information? You need to be able to give out what you have in you, no? Communicate what you need, what you have in this. Why do I have to keep telling you this? Anyway. So the abstract class, I'm saying optionally might have a pure virtual function in it. So what is the pure virtual function? Firstly, all pure virtual functions are virtual functions. All pure virtual functions are also virtual functions. So everything that we have done with the virtual function now can be done with the pure virtual function also, including late binding, for example. Right?
Yes, sir.
Secondly, what does the pure virtual part of it indicate? The pure part of it indicates is that in the base class, you will only give in the signature of the method without giving it a code body. So for example, something like this, it would just contain a signature. It's not the exact syntax, but it would not have a code body. This would not be there. Instead of this, it will only have a signature. Right? And now the derived class that is inheriting from that abstract class must compulsorily override that base class method. For a virtual method, is it compulsory to override a virtual method? A normal virtual method. Is it compulsory to override that?
No.
No,
No,
sir.
sir.
No, sir.
No, sir.
But a pure virtual function, it becomes compulsory to override that. That is the difference. Because the base class does not have the code body. It only has the signature. Right? Now in different languages, different keywords may be used. Here the keyword used is an abstract keyword. An abstract function in .NET is an example of a pure virtual function. The keyword is abstract. But in an object-oriented term, you need to know what is a pure virtual function. So here we can call them abstract methods. But when I say abstract methods, object-oriented term, you need to know what? That this is a pure virtual function. And a pure virtual function has the characteristics that we just mentioned. They will only have a signature, not a code body. And it becomes compulsory for the derived class to implement that. Are we clear on this?
Yes, sir.
Okay.
Yes, sir.
Any questions before I get into the code? I'm going to try out some code out here. Any questions about that?
No question, sir.
Just going to copy paste some of my existing code. And let's have a look at the first example out here, where I create an abstract class. Okay. So I have a class out here, which has one method display, but I marked it as an abstract class. This does not necessarily have any pure virtual function. Pure virtual functions are totally optional. The moment I make a class as abstract, first thing is you cannot create an object of that class. So that won't be allowed. So this line gives you an error. But what would be allowed would be you could inherit from that class. And now can I create an object of the derived class? Would that be okay?
Yes, sir.
Yes. Yes. So that is possible. So this is the first example when you can create an abstract class without necessarily having any abstract methods in there. Any queries about this on how to create an abstract class? Keyword use is abstract. All right. In the second example, I'm creating an abstract class which also has some abstract methods. While giving an abstract method, I'm not specifying a code body. Instead, I'm just giving in a semicolon there with just the signature of the method. Now, when you create a class, a derived class that inherits from the abstract class, it becomes compulsory to override that method. So for example, now if I don't override this, showing me an error out here. It's showing me an error out here. And the error, if you read this, says that derive2 does not implement these methods. Which methods? Display2 and display3 from the abstract class. So you then have to go and write down the code for the methods. Right? You write down the code for that. Okay. But instead of writing the code for all these methods out here, see what I can also do. Now this is a Visual Studio feature. So look at the UI. You can go to this, right? Go to the IntelliSense here and say implement the abstract class. So when you implement the abstract class, what is it doing right now? It is overriding the
Abstract methods.
Okay, it generates a code. Then of course you go and put in whatever code that you want to write. And that's how you could do that. So this is what we meant by the derived classes to compulsorily implement the code or override the code in the abstract base class. Right? Any questions, any doubts about this so far?
No, sir.
All right. Again, this is a concept that you have done before, so hopefully you're fairly comfortable with this. All right. Look at another thing that I've done here. I've created derive3, which is also implementing abstract base class too. So which means now I have to go and write down the abstract functions myself. Now, what if this class also does not want to write down the code for the abstract methods? Then you have an option of marking this class itself as abstract. If you mark it as abstract, it would mean what? Now you're not forced to write down the code here. Would we now forced to write down the code? We are not written down the code for this by marking it abstract. So who's now going to force to write down the code now? A subderived class again. So derived class of derive3 will now, if you are having any class that inherits from derive3, then you'll have to write down the code for those methods. But obviously, if I make it abstract, then you can't create an object of the derived class. So you have two options. You can either implement all the code in there, or second possibility is what? You can mark your class itself as abstract if you don't want to implement all that. Are we clear on this?
Yes, sir.
All right. So this is how you would work with an abstract class. Okay. Now, an exact opposite of the abstract class is a sealed class. A sealed class is an exact opposite of the abstract class. So what can you do with a sealed class? What can you do with a sealed class? Yes.
Its
We can
object
What is
can
create
be
objects
created.
of
create an object of the sealed class?
You
But
cannot
what is
Cannot
create
be inherited.
abstract methods in that.
Cannot inherit.
no? You can have methods in there, but you
No, I
cannot.
mean abstract methods.
No, no. Abstract methods can only be in an abstract class. So that is no. That's a no-brainer. But the second thing about a sealed class is you can only use it or you can use it as a base class. Sorry, you cannot use it as a base class. You can create an object, but cannot be used as your base class. So an exact opposite of the abstract class is your sealed class. The keyword to create a sealed class is the sealed keyword. So you have to try this out yourself. How would you create a sealed class? Public, sealed class, and class name. Try out the features that we said can and cannot be done and try that out. Are we clear on this, everyone? Questions, if any? All right. So we're out of time for this one, for this session. I wanted to actually give you an assignment, but I'm out of time for giving you the assignment also. So I'll give you the assignment in the next section. Please try out this code thoroughly. Those who have not finished your earlier code, you also have time to try and finish up this code in between and then move on to the next one. Okay.